Good afternoon, good morning, good evening, good whatever time it is where you are. Today we are going to be talking about deploying a prediction model using a microservices architecture, specifically Kubernetes. I'm doing everything locally, so I'm using Minikube as my Kubernetes version. I will be pulling data from the Dutch train network NS, and for the current data on disruptions. So how many minutes delay there is throughout the day. I'll be using historical disruption data from this company that I've forgotten now, and I will be pulling weather data from OpenMeteo with the aim of predicting the amount of disruptions based on weather data using a XGBoost model, so a tree-based model, serving it as a REST API using Fast API, and then viewing all of this in a Streamlit dashboard, similar to Plotly Dash. Streamlit is a really nice, easy Python implementation of creating dashboards. So let's get started. There are kind of three parts, four-ish parts to this setup, which we will go through. Setting up MySQL as a microservice, uploading the data that we have, which is just two CSV files that we will incorporate into this MySQL database, creating the middleware, which is then the model and the API endpoint, and then running the dashboard. So this is a ton of Kubernetes and Minikube commands. This is that, and this is that. So we have kind of three sections to kind of work our way through. So let us get started. We will initially start the Minikube engine, so we can run our commands. I will likely jump a couple times in this video because things take a while to run. So do not be too disconcerted by that. In any case, we now have Minikube running, and then we're going to start applying our various volume requests. I can show you these YAMLs in a sec, but basically what we are doing is provisioning compute spaces, like the persistent volumes, basically that we're going to use to put our MySQL database on. The YAML that is used to kind of specify how it's being deployed, and also what the service itself kind of looks like, because we need to provision some kind of entry point to the MySQL server once it's existing. So we run all of these YAMLs and their various applies, and then we will see if our deployment looks as we think it should. You will see kind of this describe being used a bunch, but basically these are then what we specified in the YAMLs. The names, any kind of passwords and stuff, the way that we want it to spread, if we want it to spread, the image that we used, we happen to be using MySQL 8, the port that it's being hosted on, the password that we set. In this instance it's password, which isn't very safe, but this is just a demo. In your own things, please be better than me. Some general information about the persistent storage that we specified, the volume claims and so on. So that's all looking pretty tasty. And then we can just check that the pods are running. So this is then our kind of entry point. And Yeah, we did that. So yeah, and then we need to run. Oh yeah, this is optional. So there are a couple of things you can do. You can already start interacting with this database via various scripts, but you could also run MySQL directly in your terminal. You just need to make sure that things are as expected. So basically, this is just a command: find the MySQL instance that you've got, which our image is MySQL 8. Don't restart it. Use the MySQL client that's kind of default. The MySQL client that's default for my instance. All of this, by the way, is being run on a Mac OS system. Put the password in. Put the the information necessary to get to the table, and then just to show that the thing is running as expected. We can just run some examples so we know our database is running. We've got our information schemas, the table, MySQL table, etc. That we expect when running just a default MySQL table database. So to get out of that, we do a Control D, and then we get our by statement. So all well and good. Nice. And now we need to expose an input. We need to expose what's it called? We need to expose the port that we can then access externally. And to do this, we just need to make sure that we have. I should have run something else beforehand. That was a bit silly. We need to expose the pod with using kind of like a load balancer so people can access our SQL database from remote using the port that we set up. But for this, I need to know the name of the thing that we're going to use. So in this instance, we're using expose again, and then specifying the port that we are exposing it to, and then we can just replace the name that we have with the name that it now is. Bear in mind, every time you redo this sort of thing, often the ports will change, and often, well, always the names will change. Cool, and now that should be running okay, and to make all of the services be available to each other, you need to, this is only a Minikube thing, by the way, this isn't a Kubernetes thing. You need to create a tunnel that like information can be passed within. So open a new terminal and just casually run my Minikube tunnel, and then this will just continue in the background. For like main deploys of this sort of stuff, you don't need to worry about it. Yeah, and then when you have this tunnel, you can check that your service is there. So we have the Kubernetes server that is running. We have the MySQL backend that we have, and now we have our load balancer, essentially our entry point into our MySQL tables. So, next one. Excuse me. Let's upload the data now. So we've done this part, and now we're going to do this part. So this is just a simple Python script that will connect to the new instance and print a bunch of stuff, and then try to connect. If it can't connect, then it will throw an error. And then it will connect to a new table that's been created in this step called quote-unquote train data, because this is then the disruption data that we're uploading. And we will pull the files that are in data, which are currently just these two. They're just CSV files with data on the amount of times that there are disruptions on different dates and so on, plus extra info. but we only really care about the disruption time at the moment. It will try to upload this data frame that we created from all those CSVs, and if it already exists, it will throw a value error saying that the table already exists, and then it will attempt to read in the raw data. Yes, so let's do all of that, shall we? Bum, 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 bum. Cool, 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 cool. So this is the moment where we're actually uploading. And then this is just the pull, and then if it has gone well, then we will have data in this new data frame, which we do. So wonderful. Beautiful, that script's done then. So let's move on to the middleware. Yes, here's the middleware, and so this, all of the code that is necessary for this is hosted in here, Model API. Basically what we're going to do is use a pre-trained model. This is XGB model. This was trained earlier using just various sklearn for grid search and XGBoost and so on to train a model using the SQL data that we had. I'm not going to go too much in depth into this. Look into learning how to train models and export them, essentially using this save model from grid search from XGBoost. This will output to the model format that you then have here, and then we're just taking that and serving it using this model API that we've created. I go more in depth into like the model itself in the Databricks version, if you're curious of the deploy. Cool. Where was I? Yes, so we need to cd into the model API folder. Because we're using Minikube, we need to specify where our Docker image is built to. So this is just set the Docker env to be quote unquote in Minikube. And then we can just simply Docker compose build our model API. So this is then based on this Docker compose file, just creating a container with the image of the API in it and serving it at port 8000 using this Docker file. So use Python 3.10, grab everything from this directory, copy across the requirements, install the requirements, and then run the code using Uvicorn. Uvicorn is just a way of running a HTTP server locally. So then at the end of it, we'll have a port. We'll have the API running on localhost 8000. At least that is the plan. And hopefully it finishes running soon. Might need to speed this up a little bit. Oh no, there it goes. Nice, so we've got our build, and now we need to run this Docker image. Remember we saw xgboost-api-i in the Docker file, Docker compose, excuse me. So if we do that and check the pods that are running, we should be able to now see a new one. So this was our MySQL load balancer, and then this is our model API. You can specify the name here if you don't like model API. But in any case, that exists now, and now we're going to expose this via another load balancer. So now we have a service running. And you can also see that we're starting a tunnel for the new service because the Minikube tunnel is just running in the background, and any new service it gets will just kind of sort itself out, which is kind of nice. And now let's see if it works as expected. and it does, so that's exciting. So this is where the API is hosted, and then because we're using Fast API, you get docs immediately out of whatever you make. In this instance, it's a very simple API. There's only really one main endpoint. I mean, we have our root, which just says, welcome to this API. But the main one that we find interesting is the post request here. So we have some example data. Here we're just saying we want the mean temperature to be 18, min 11 centigrade, max 25 centigrade, and over the day we've seen 3.2. I think it's millimeters. I need to double check. I'm not sure of the unit of that, but 3.2, whatever that unit is. And so we post this JSON to our endpoint, and if it all goes well, we should get a prediction. So based on this weather, we predict that there will be 1,461 minutes of disruption time on this day. So it lives. That's exciting. We can ignore that now. So we're on our way. We've got middleware done. Let's go to dashboard. The dashboard setup is pretty similar to the middleware. It's essentially basically the same idea. So let's come out of the model API folder to the root. All the files that we need are so the app, the compose, the Docker, the Docker file, excuse me, some utils that we're using, and the requirements that are required for the dashboard. A lot of this we don't need to do. I forgot to say that Minikube comes with a dashboard itself. It's kind of fun to play with. Let's just make a new one real quick. This will just run up a, I believe it's Flask. I believe it's Flask dashboard. And we can see everything that we've done so far in this Minikube dashboard instead of having to run all of our things manually. So there are kind of three main things that Kubernetes works with: the deployments, the pods, and the quote-unquote services. And then we also have replica sets of like how many versions of whatever to like deal with lots of people wanting to use your stuff, but we can use this to get more information on our models. So remember we ran, was it kubectl get pods, and it gave us basically this information that is running, whatever the endpoints are, if we got those. Yeah, so our IPs, the ID that's been given to it, like how it worked out. Pulled, created, just generally more info on what's going on, which is kind of handy if you're having problems deploying certain things. That's kind of cool. It's kind of cool add-on that you get this dashboard alongside it. But for the moment, we are terminal bosses, so we don't super need to worry about that. We already did this for the model API, but if you've not, you need to set the Docker environment. And now, because we are no longer in model API, we're in the root, we're going to Docker build from these two. I will run that and show you what the files look like. Very similar as before. Instead, it's now referencing the dashboard, so the container and then the image. And now instead of 8,000, we're using 8080 to deploy the thing to, the port to deploy the thing to. If you reuse ports, then you'll have problems because your backend can't assign multiple things to the same import. So be aware of that if you're doing this sort of thing. The Docker file, because we're using Streamlit, the entry point is slightly different, and we need to deal a bit with some various options from Streamlit because Streamlit isn't inherently used to being deployed via Docker, and needs some extra kind of options being selected. Otherwise, it's sad. I think we can speed this section up as well. Okay, and so our Docker Compose build has just finished. So let us continue. What we're going to do now is run this pod based on the image that we just created. So based on weather-i, we are now creating weather-dash. Never thought about that, but this weather Strapier dash. And so now the pod exists. Just to double check, we will get the pods. And now we see not only the model API that we have running from earlier, and the MySQL entry point. We also have now our dash. Nice. And now we can expose this using a load balancer for us to then look at. And if that has all gone to plan, as expected, we should be able to now see our dashboard, which is the case. So based on this latitude and longitude, which is Amsterdam, we are able to say stuff about the prediction and what the Dutch train company says about the disruption. So this is our prediction based on our API, and then this is what the train company itself says the amount of time they expect today that there are disruptions. So our prediction is a little under, but not too far off. And also we are able to just have interest, see the weather that we can expect. So yeah, this is based on the mean, I believe. Need to double check. Oh no, this is just the raw, of course, excuse me. So in Amsterdam in the next week or so, we can expect these sorts of temperatures apparently. This amount of rain. So going to be quite dry next week apparently. Apart from on July 11th, we might get a bit in the middle of the day or so. And then just to visualize the prediction based on these four numbers, we are getting the result that we are getting. Excuse me, I've been at this a long day. But yeah, so basically that's what we've got. We have then of course our thing done using Minikube and Kubernetes. We've set up three distinct things: the historical data as a MySQL database, a API endpoint with a prediction model in it, and a dashboard which not only pulls results from this API, but also grabs data from NS and shows it, and also grabs data from OpenMeteo and shows it in our dashboard. So yeah, thank you for watching.